What grades are here? What grades are here? What grades are here, guys? What grades are here? Morning, afternoon, good evening, good everything. Who's here? Hi, on Tatile. You tell me which topic I should deal with. What do you want? What grade are you in? What do you want? Hello, Mrs. M. Is it Mrs. M? Hello, Mrs. M. What would you like? What grade? What would you like? Yes, okay. Grade 12 trigonometry. I'll be continuing with that tomorrow. So let's hold back on that one. Caveats a grade 11. What there? Teddy bear algebraic expressions with fractions. On Tatile. One-on-one. Why would you like one-on-one? Kiabe, the nature of roots. What are you struggling with nature of roots? Compound angle, I promise there. My attention span isn't the best online. Oh, I see. Yeah, I get your predicament, especially when you are saying you need an in-person tutor. The thing is, given my time constraints, in-person tutor is very difficult for me. I'm sure geographical location would be a challenge for the both of us. But if you mean like one-on-one, as in like you wanna do one-on-one online, then I would have to also like check time schedule. Mrs. M, I did a full session. You can go onto my YouTube channel. I did a full session yesterday with the grade 10s, literally covering almost all avenues of the grade 10s. I did that yesterday, full on. You can check out the full session that I did yesterday. It was 3 hours. Like the grade 11s had me on a stronghold, chokehold, literally, and I was backed to a corner there, just doing all sorts. You can imagine. So please do check out that session. It's there for your perusal. You can please give it your attention. Give it your attention, please. Give it your attention. Yes, I did. Posted it on YouTube. I actually even like advertised it a bit, so you can check out the page, the TikTok page. I advertised it a bit with its thumbnail. The most recent video that I've posted on my YouTube is that grade 10 session that I covered yesterday. So please do check it out. It is there to be checked out. It's there to be checked out, and it's there to assist and help those who need the help, however they need it. So please go there and check it out. So I won't do anything that's grade 10 related. So let's see. It seems like people are saying, no, there's no specific grade today, guys. No specific grade. Okay, the person who said nature of roots. Okay, grade 12, I will not be attending to any of your pleas or your cries or your thingies, but because I have a session with you that's lined up for tomorrow. Yes, Kiabets, I only do maths, unfortunately. I only do maths at present, but don't worry. With time, when the maths and the physics will come together and they will play together and we'll have fun with both. But not for now. For now, I'm just looking exclusively at maths, just trying to get this maths section going down. Remo, the grade 12 session, I have a grade 12 session at 5 a.m. So it's for the early risers. It really is for the early risers. 5 a.m. 5 a.m. until 6:30 in the morning. So that's just like before you guys head out to school anyway. Some of you are probably preparing to go to school at that time. But yeah, I run the session that time anyways, and then upload the session afterwards on the YouTube channel. So for instance, last week, the sessions that I covered on trigonometry are already on the YouTube space to be watched, to be reviewed, to be checked out, your own pace, own time, without actually anyone interfering, and so forth. And you know what's nice as well is that in the mornings it's like so peaceful and quiet. There's no one to interfere, no kids making a noise in the background, as is the case right now, and so forth. So yeah, Mrs. M, like I said, I did a revision session with the grade 10s already for 3 hours, for crying out loud. So check it out. Check out the YouTube channel. Bio, go to my bio. The link is there. It's called Maths is a Game 5 to 7, but you can check out the link on my bio on the Maths is a Game TikTok channel. Check out my bio there. You should see the link is there, the YouTube link. It's called Maths is a Game 5 to 7. And the most recent video that I uploaded was the grade 10 3-hour session that I did with you guys yesterday night. Like I slept late yesterday night. Thank you so much. God bless you too. Alright, so I had a few requests from grade 11 to do reduction and then also nature of roots. So I'm going to do one question with reduction. Okay, 180 minus x minus 2 cos 90 minus x into cos x over 2 cos squared 360 degrees, sorry for the writing there, 360 degrees plus x minus cos into negative x. Okay, so this is a problem that has to do with reduction. Okay, so obviously this is a question where they will say simplify. Okay, and what you should observe then here is that we have sine 180 minus x minus 2 into cos 90 minus x times cos x over 2 cos squared 360 plus x minus cos into negative x. Okay, so guys, for a grade 11 learner, reduction is of utmost importance. Okay, I'll do one reduction, and I think there was someone else that said nature of roots, so I'll cover some nature of roots as well. I think it was Man Million that said trigonometric reduction, so I'll check that out for a little while, do a few problems there. And then I saw Giabetswe also, who's actually on the call, said nature of roots. So I'll check those out, both of them today. Maybe that's basically the substance of what I'm going to check out for today. And I guess grade 11s, you are in luck because this is your guys' stuff. Grade 12s as well, obviously. The grade 11 content is of importance to you. You need to know it as well. So if you look at the top, sine of 180 minus x. So what you need to know here is the Cartesian plane. Right, on the Cartesian plane, guys, you have 90 here, 270 there, you have 180 here, you have 0 here, and obviously you go anti-clockwise, 0, 90, 180, 270, 360. This quadrant is called the 180 minus quadrant. Here, sine is positive. This is called the all trig ratios are positive quadrant. Okay, here This is where tan is positive. This is where the 180 plus quadrant. Makes sense because 180 degrees plus something, this is like positive. Then 180 minus, this is the second quadrant, and then this quadrant is called the 360 minus quadrant. If you notice something, all of these I've named them according to the horizontal angles. So we have 360 and 180. This is 180 minus, 180 plus, 360 minus. Okay, so when we reduce, right, within this 1 unit circle from 0 to 360, we always consider the function value, we reduce it to an acute angle, and then basically we check what is the sign of that particular quadrant where that function value exists. So let's look at this, for instance, sine of 180 minus x. First question, 180 minus x is in which quadrant? It is in the second quadrant. How is sine in that quadrant? It is positive. All other trig ratios, obviously cos and tan, would be negative in this quadrant. So we know that we write sine of x. So this 180 minus falls away, and then we write the acute angle. This is assuming that this x angle is an acute angle, meaning it's an angle between 0 and 90 degrees. So 180 minus falls away after we evaluate the trig ratio in that quadrant. It is positive sine of the angle x. We move on, minus. Now, cos of 90 minus x. Now guys, 90 minus is not, so we have what we call function values, and all function values are simply these: 180 minus, 180 plus, and 360 minus. These are called function values. Then we have what we call co-function values, and these simply are 90 minus, 90 plus, 270 minus, and 270 plus. What's unique about these is that whenever we evaluate or reduce co-function values, sine will change to cos, or vice versa, cos will change to sine. Okay, so let's look at this. 90 minus, where is 90 minus located? 90 minus is in the first quadrant. 90 plus is in the second quadrant. 270 minus is in the third quadrant, and then 270 plus is in the fourth quadrant. So this speaks to your function, co-function value. So I'm gonna just use my green. Okay, green, 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 green. Because I just want to distinguish between my co-function values and my function values. And for where my function values are, let's use blue, blue, blue. So once again, just want to repeat, function values are 180 minus, 180 plus, and 360 minus. All that simply happens here, we evaluate the function value and we check the sign of the trig ratio. That's it. For our co-function values, on the other hand, 90 minus, 90 plus, 270 minus, and 270 plus, whenever we evaluate or reduce the co-function value, two things happen. There's a sign change that happens if that is applicable for that particular quadrant, and there's also a change in trig ratio. Okay, sine changes to cos, cos changes to sine. So we just need to remember this, guys, that there's function values and there's co-function values. So here is a co-function value. We have negative 2. This cos 90 minus x, we need to evaluate that. 90 minus x is in the first quadrant. How is cos in that quadrant? It is positive because all trig ratios are positive. So then we have the negative 2 already. But then when we evaluate the cos, it becomes positive cos No, not positive cos. It becomes positive sine x. Do we see that, guys? Cos changes to sine because this is a co-function value. Do you see the mistake I nearly made? Because I just went ahead and wrote cos. But remember, since it's 90 minus, it's a co-function value. And what did you say about co-function values? Sine will change to cos, cos will change to sine. So in this case, we have a positive sine x. Okay, times the cos x over. Now here we have a 2 and then we have a cos squared 360 plus x. Now this is an angle that is greater than what? 360. So what do we do with angles greater than 360? So I'm just going to write some notes here. Whenever we have angles greater than 360 degrees, we subtract 360 until we enter the 0 to 360 interval. Okay, now for this one, this is 360 plus x, so this is greater than 360. Okay, so what we do is we subtract 360, and when we subtract 360, what happens? We get cos squared x, and that's just that, guys. Cos squared x. Okay, that's it. Done and dusted. Nothing more than that. Then we follow it out with negative. This is grade 11, guys. Negative cos. Now the thing is, cos of negative x, this is a negative angle, so what do? We add 360. But remember, when we add 360, this is like 360 minus x. This is our, what quadrant is this? This is the fourth quadrant. In the fourth quadrant, how is cos in the fourth quadrant? In the fourth quadrant, cos is positive. Okay, cos is positive. So we say cos of theta. Okay, sorry guys, this is very untidy. So we have sine x minus 2 into sine x. I just want to write this out neatly. Times cos x, cos squared x, minus, when we evaluated this, we added 360. 360 minus x is in the fourth quadrant. How is cos in that quadrant? It is positive. So we write positive cos x, okay, in brackets. But there was already a negative there, so a negative times the positive will revert back to that negative sign. So now what do we have? We have negative sine x minus 2 sine x times cos x over 2 cos squared x minus cos x. Now when you look at this, okay, there's nothing more that we can do. In the top, we cannot add or subtract like terms, okay? In the denominator, there's no like terms, okay? So what we can then do, no simplification in the numerator and the denominator can happen. So we look at the next thing that we can do, and that is factorize. So if we look at sine x minus 2 sine x times cos x, there's factorization that can be done in the numerator. Okay, I'm sure you guys can see that. If you look at the denominator, there is factorization that can be done in the denominator. Okay, and what we constantly do whenever we are simplifying is we constantly are jumping between three important strategies, and that is simplification, factorization, identity. We are constantly jumping between these three important strategies: simplification, factorization, identity. So in this case, we have simplified sufficiently. We applied our function values. That's a simplification strategy. When we are applying these function values, evaluating the function value here, 180 minus x, which quadrant? Second quadrant. How is sine? Sine is positive, sine x. Evaluating the co-function value, cos 90 minus x, which quadrant? First quadrant. How is cos? Cos is positive. But then we write sine of x, retaining the negative 2 obviously because it was already there, but we have a positive sine x in brackets. Cos x staying the same. Evaluating the 2 cos squared of 360 plus x, subtracting 360 because this is an angle greater than 360, getting 2 cos squared x. Evaluating the negative angle, adding 360 to negative x so that we can have the 360 minus quadrant, the fourth quadrant, where cos is what? Positive. Writing cos that's positive in brackets and retaining the negative sign. Then sine x minus 2 sine, 2 times sine x, 2 sine x cos x over 2 cos squared x minus cos x. Simplification done and dusted. Then we ask, is there anything more to be simplified? No. We move on to the next strategy, which is factorize. Is there anything that can be factorized in the numerator? Yes. There's the highest common factor in the numerator. What is that highest common factor? If we look at the denominator, is there anything that we can do as far as factorization? Yes. There is a highest common factor in the denominator. So let's go. Let's factorize first in the numerator. So in the numerator, we take out sine x as a highest common factor. What are we left with in brackets? 1 minus 2 cos x. Go down to the denominator. Factorize in the denominator. What can we factorize? We have a highest common factor, which is cos of x. What are we left with inside the brackets? We are left with 2 cos x minus 1. Okay, so you guys can see we have 1 minus 2 cos x, we have 2 cos x minus 1. But I'm sure you guys can see something here, that after factorizing, you would think we are done with factorizing. Okay. Mahaila, you are asking, can't we change cos squared to sine squared x minus 1? Okay, remember that when you do that, then basically you are going to have to also deal with whatever you have. All right, sometimes when we do something, we need to first think about what consequences it will have for us as we continue working. Okay, and then what I would advise you to do then, is to go ahead and do that, and then see how do you go about simplifying from that stage. Okay, what I am suggesting is that there's a strategy, a 3-point strategy that we can always apply when we are simplifying simplifying trigonometric expressions of this nature, and that is, we need to first check, can we simplify applying what we know? Addition and subtraction of like terms, is it there? If it's not, then reduce, okay, each respective trig ratio. So if the reduction is possible, then that's a type of simplification. We reduce what we need to reduce. After reducing, we get to a certain point or stage in our question where we ask, can we do any further simplification in that particular stage? If not, then we move on to the next strategy, which is factorization. When you look at the numerator here, factorization is definitely possible. So we apply the next strategy, which is to factorize. So we apply that fully before we move on to checking if is there any identity that we could apply into the problem. So for me now, I'm looking at this top and bottom, and I'm seeing factorization. So I'm applying the factorization strategy at the top and the numerator, and I'm applying the factorization strategy in the denominator. So when I do that, it makes life very easy for me. Okay, and even when I look at this, I'm like, okay, can I factorize any further in this particular question? Now to me, I look at this bracket, it is nearly similar to this one. So I'm looking at this and I'm like, there's another factorization strategy I can apply for the brackets to be the same. And that is what? So I'm going to do this. I'm going to apply the sign change rule. Yeah. Liabona, can you please look at the question? Because you're asking me a question about how did cos turn to sine x. Okay. And the thing is, I just looked at this here. Okay. And please, guys, if you guys are not paying attention to the little things, like the fact that if it's a function value, obviously there's no change in trig ratio, but if it is a co-function value, 90 minus 90 plus 270 minus 270 plus, when you reduce a function co-function value, sine changes to cos, cos changes to sine. That's what happens for co-function values, 90 minus 90 plus 270 minus and 270 plus. It only happens with co-function values. With function values 180 minus 180 plus and 360 minus, there is no change in trig ratio. The trig ratio will remain as it is. The only thing that changes is the sign, if the sign is supposed to change in that particular quadrant. Please pay attention to the co-function values and the fact that sine changes to cos and cos changes to sine. That is why here, when we evaluated cos 90 minus x, 90 minus is in the first quadrant. In the first quadrant, cos is positive, but then we write the trig ratio sine instead of writing the trig ratio cos when we are reducing this co-function value. Okay, so that's why cos changed to sine, and then we proceeded after reducing all of these trig ratios to get to this stage, which got us to this stage when we multiplied out. Now we ask, can we simplify any further? It's very clear that here we cannot simplify any further. So what do? We move on to the next strategy, which is factorization. Look at the numerator. Can we factorize anything? Yes, we can. You can see here sine x and sine x are highest common factor. We take out the sine x. Look at the denominator. Here you can see that cos x is the highest common factor. You take it out. You can see that these brackets are nearly similar. So we apply something that we learned in grade 10, which is called the sign change rule. So what I do is I change the sign of sine x on the outside. This allows me to do this at the top. Do you remember, guys, the sign change rule? You would have something like this, 4 minus x. Then what you could do is you could take out a negative sign, rewrite this as x minus 4. 4 minus x could be rewritten. You took out a negative sign, and that allowed you to swap around x and write x first and 4 last. Because when you take the negative back, what's negative times x? You get back the negative x. What's negative times negative 4? You get back the positive 4. So by taking out that negative sign, it allows me to change around these two terms inside the bracket because they have a minus sign in between. We know that these two brackets are not the same. Why? Because it's like saying 1 minus 2 and 2 minus 1. Do you get the same answer when you say 1 minus 2 as opposed to 2 minus 1? I don't know why it's blurry now, this thing. 1 minus 2 is obviously negative 1. What's 2 minus 1? It is positive 1. These two things are not the same. So to make them the same, you take out a negative sign, and then that allows you to change the order of the two terms. 2 cos x first, followed by negative 1. We call this the sign change rule. It is a factorization strategy that you learned in grade 10. The sign change rule. 4 minus x can be written as x minus 4. All you do is you take out a negative sign that allows you to then swap around the terms, retaining the negative sign, because when you take the negative sign back to the x, you get back that negative x. What's negative times a positive? Negative x. Negative times a negative 4, you get back that positive 4. So that's what I did here. To swap around 1 minus 2x, I took out a negative sign, So sine x is no longer positive, it's negative sine x. Then I swap around the 2 cos x and the 1. I get 2 cos x minus 1 over cos x into 2 cos x minus 1. Now do you see that these brackets are the same? Now I can go ahead and do the following. That is, the relationship between sine x and 2 cos x minus 1 is multiply. The relation between cos x and 2 cos x minus 1 is also multiply. So I can cancel the 2 cos x minus 1s. They are out of the picture. That leaves me with 1 and 1. Then what am I left with? Negative sine x over cos x. But this, all right, I'm sure now we have factorized, right? And then that factorization, after we are done, we ask, is there anything else that we can simplify? Oh yes, we can simplify, meaning we can cancel these two, which leaves us with negative sine x over cos x. Now that we have negative sine x over cos x, we ask ourselves, this was the simplification step, the cancelling, all right? Remember, I factorized. After I factorized, I go back to this strategy and I ask, is there any further simplification that I can do? So when I'm here, is there any further simplification? Yes, there is. You can cancel these two. That leaves me with negative sine x over cos x. Then I go back here. I ask, after simplifying, is there any further simplification? No. Is there any further factorization? No. Is there an identity that I know that can help me convert this to a single trigonometric ratio? Yes. Yes. So that single, like Tebucho has said, is negative tan x. Maybe you're going to ask me, where do I get that? Remember, with your identities, there are two major identities that you learn. Sine theta over cos theta is equal to tan theta. This is called the quotient identity. And then there's another one. Sine squared theta plus cos squared theta is equal to 1. We call that the square identity. So in grade 11, you must know these identities. All right? Very, very important. And remember, the square identity, you can further say sine squared theta is equal to 1 minus cos squared theta, or cos squared theta is equal to 1 minus sine squared theta. So that is how we simplify that. This is how we simplify that problem using the 3-point strategy: simplify, factorize, identity. Guys, when you use this strategy, you can never go wrong. You can never go wrong. Okay, someone said I must do another one, so let's do another one. Let's do another one. Let's do another one. Sine 180 minus theta times sine of 540 minus theta times cos of theta minus 90. This is grade 11, Musa. Over tan of negative theta times sine squared of 360 minus theta. Okay, this looks like a nice, meaty, munchy problem, guys. How many marks do you think? 7 beautiful marks, guys. You, who wouldn't want to chow such big marks? Looks tasty, delicious, looks delectable, if you ask me. So if you look at the top, you can see it's multiply all the way through. If you look at the denominator, it's multiply all the way through. Okay, so our first strategy of approach is we must what? Simplify. Tasty meal, guys, for grade 11. It looks beautiful. Like I can see this is like a 7-color, a full course meal on a Sunday, if you ask me. All right, can you see the meat, guys? Can you see the veggies? Can you see the dessert? Yeah, it looks good. So first point strategy, you must first grab your knife. You must first grab your knife. S is simplify. Okay, Okay, we need to first apply a simplification strategy. If there's addition and subtraction of like terms, we do it. If there's BODMAS that can be applied, brackets, exponents, division, multiplication, addition, subtraction, BODMAS, we apply it, guys. But if there isn't, then of course we must simplify using our reduction. So here we can see it's simplification using reduction. So let's start off there. That is a simplification strategy when we are reducing. Reduction is a simplification strategy. We are going to apply it. So let us apply it. Sine of 180 minus theta. Quadrants. 180 minus theta is in which quadrant, guys? All students take care. It's in which quadrant? 180 minus theta. Maybe you guys can tell me. Let's do it one step at a time so that I don't lose anyone. Thank you, Mahaila. It is in the second quadrant. Sine is what in the second quadrant? Is it positive or negative? Sine in the second quadrant, is it positive or negative? Thank you, Mahaila. It's positive. Miss Shope, Remoa, Travis, Didi, it's Puti. You guys are 100% spot on. So we write positive sine of theta. Then now I insist we put brackets around the sine theta once we get the answer. Remember, the relationship is multiply. We look at the next one. Sine of 540 minus theta. What do you observe 540? 540 is an angle that is greater than 360. So we have angles greater than 360. So what do? We grab our calculator, and what do? We subtract 360. Yes, we subtract 360. What do we get in our calculator? After we subtract 360, do we get an angle that's between 0 and 360? Yes, we get 180. You guys are amazing, sis. You guys are so amazing. So our new function value is sine 180 minus theta. I'm going to hold it right there. I'm going to move on to the next victim. Cos theta minus 90. We have an angle that is less than 0, negative 90. So what do we do to that? We grab our calculator, we do what? Here we subtracted. Here we must do what? We must add. We must add 360. Thank you. We add 360, and then what do we get? When we add 360, guys, before we evaluate the function value, I know you guys are very excited, we'll get there. Please add 360, what do you get? 270. Thank you so much, Mr. Kachiso. Cos of 270 plus theta. Oh, we are getting somewhere. Okay, then we have tan of a negative angle. Here's another negative angle, guys. What do? We just add another 360 there. When we add 360 to this negative angle, we have what? 360 minus theta, because we added 360. We added 360, we get 360 minus theta. We know what quadrant that is in. We'll come back to it. So things are good. Here, we are sorted. We are already in there. We know which quadrant this is. We know almost which quadrant this is, guys. What quadrant is this? It's in the 360 minus theta. What quadrant? It's in the fourth quadrant, right? But I just want to reveal something to you guys. It's in the fourth quadrant. So if you evaluate sine in the fourth quadrant, sine is what in the fourth quadrant? In the fourth quadrant, sine is negative. So what we do, we evaluate what's inside, and we put the square outside the bracket. Okay, so there's just something to note here, that whenever we are evaluating this trig ratio, this function value, and there is an exponent, we must evaluate this thing and then put the exponent external to what we get. Then we are going to apply the exponent inside, which will always lead to what kind of answer? A positive answer. So we always get a positive answer out of a square trig ratio. Always, guys, always. But I evaluated so that you guys can see that when I apply the square, you are going to see in the next step. Let's go. Sine theta, we already have. We are happy with our sine theta that we got from sine 180 minus theta. 1 mark will be applied there. 180 minus theta, what quadrant is this? 180 minus theta, Yes, it's in the second, not the third. Please, let's be careful about that. 180 minus this is in the second quadrant. How is sine in that quadrant, guys? Positive or negative? Very positive, guys. Thank you so much. Very, very positive. You guys are so positive as well. It's making me so excited. Very positive, very positive. I retain my brackets, guys, after my evaluation. Yeah, now we are here. Cos 270 plus theta. Do you guys remember what we said about 270 plus theta? What kind of function value is this? It is a co-function value. So what happens to cos? Yes, it's a co-function value. So what happens to cos, guys? 270 plus is in which quadrant? It is in the fourth quadrant. How is cos there? It is positive. But then do we write cos? No, we write the co-function value. We write sine. Remember, we ask ourselves, 270 plus is in which quadrant? It is in the fourth quadrant. How is cos in that quadrant? Cos is positive, but then we write positive sine, the co-ratio. We write the co-ratio sine, but we evaluate for the sine. We'll ask, how is cos in this quadrant? We don't ask how is sine in this quadrant. We ask how is cos in this quadrant. We're always asking how is that given thing in that quadrant. So here it's no different. We're asking how is cos in that quadrant. It is positive, but then we write the trig ratio, that is the co-ratio of cos, which is sine theta. Okay, hopefully you guys get the point. Let's go down. 360 minus theta is in which quadrant? It is in the 360 minus theta is in the fourth quadrant. Very good. How is tan there? But it's not in the third quadrant. 360 minus is in the fourth quadrant. How is tan there? Tan is negative. Very good. Negative tan theta. Thank you very much. We put it in brackets. Then of course you remember that minus sine theta, we had evaluated 360 minus. It is in the fourth quadrant. We said sine is negative, but then since there's a square, we put a bracket. We put the square on the outside. When we apply the square into the bracket, we get an answer that is positive. We get a positive sine squared theta. Guys, do you see how easy this is? Do you see how beautiful this is? Ha, ha, ha. Now it's time to play further simplification. You guys are ready for the cancellation game? The cancellation game is very possible. Why is the cancellation game possible? Because the relationship between sine, this sine, and this sine is all multiply. Then this line stands for divide. Negative tan theta is also multiplied to sine squared theta. So basically cancellation game is full on. We can cancel across multiplication and division. The only thing we cannot do, we can never ever do, is cancel across an addition or a subtraction sign. Now I don't know where you are lost. You must tell me where you are lost. Where exactly are you lost? Because if you don't tell me, then I won't know. But if you tell me where you are lost, I will help you exactly where you are lost. Okay. So if we do the cancellation, take this sine theta, says goodbye to one of the sine thetas. Then we know at the bottom we are left with a particular sine theta, right? Then we take that sine theta, we cancel that second sine theta. So we have these sine thetas gone together with the two sine thetas. Okay. Yeah. Now let's answer these questions. Innocent and Iazidikile. How did cos 270 change to sine? Let's go back to my beautiful notes. Those who came maybe a little bit later in the session, I distinguished between what we refer to as function values. Function values are 180 minus, 180 plus, 360 minus. This is in 10 to 360 revolution. Okay, so basically 180 minus, 180 plus, and 360 minus, these are what we call function values. And when we reduce them, the trig ratio does not change. The sign is the one that is affected. Whereas co-function values, we have 4 of them. 90 minus 90 plus, 270 minus 270 plus. This here are what we refer to as co-function values. Something special happens when we are dealing with co-function values, and that is sine changes to cos and cos changes to sine. So that's why, for instance, for those who were watching and they saw me dealing with 270 as a function, as a co-function value, I did not play around, guys, when I was reducing 270 plus. 270 plus is in which quadrant, guys? 270 plus is in the fourth quadrant, right? How is cos in the fourth quadrant? Cos is positive. But then I write the trig ratio that is sine, because cos changes to sine. Are you with me? So that's why 270 plus theta gave me positive sine theta. The change in trig ratio happens because this is a co-function value. All co-function values lead to a change of the trigonometric ratio. Okay, so 270 minus, 270 plus, 90 minus, and 90 plus are all co-function values, and we reduce them as such. Okay, now also to those people that are asking about sine squared of 360 minus theta, people, I want to write just on the side that whenever we are reducing a square trig ratio, all right, okay, 270 minus kaloku innocenti, okay, is in the third quadrant. 270 plus, on the other hand, is in the fourth quadrant. Remember, 270 is here on your angles. So 270 plus, okay, it's 270 plus something, whereas this side it's 270 minus something. Remember, when we are measuring angles, we are measuring in an anti-clockwise direction. Okay, that's why here we say this is 90 minus. Okay, this one is 90 plus this side. You're with me? Then if we're looking at 180, we say this is 180 minus. If we're looking at this side, this is 180 plus, because we are measuring in an anti-clockwise direction from 0 to 90 to 180 to 270 to 360. That's why. Hopefully that makes a bit more sense. Let's come here. A square trig ratio, guys. When we are evaluating a square trig ratio, we should actually be doing this first. We take out the square, then for that trig ratio, we write the function value, and we evaluate the function value alone without the square influencing. So 360 minus is in which quadrant? It is in the fourth. How is sine? Sine is negative. Are you with me? But then the square is waiting to come and take over and affect things inside. Are you with me? When that square is applied, as even exponent applied to a negative sign makes the negative sign become positive. So that's why the answer is sine squared theta. In your memos, in your papers, guys, what you actually find is that in memos, they simply move from this step, this original, to just this answer, because the idea is that whenever you are evaluating whatever function value, okay, 180 minus, 180 plus, 360 minus, the sign of that particular function value, whether it's positive or negative, the square will lead to it being positive, whatever it is. Okay, so that's why we say sine squared of 360 minus theta. In your memos, you actually find that they write this particular question and then they just write this answer. Okay, so that's basically it. Okay, yeah, so hopefully that makes a bit more sense. So you guys, I was here in this step now, and I was interrupted. This sine theta and this sine theta, like I said, so this sine theta cancels one of the sine thetas, but then there's a sine theta that is left because this is squared. There's two of them. So when we cancel that, it's gone. But then one is left. So that one left, it cancels with this one. So what we have left over now is we have sine of theta divided by negative tan theta. Okay, remember this line stands for divide. So if I write sine theta divided by negative tan theta, this is simply sine of theta divided by, remember, this here is our quotient identity. I can change this quotient identity to what? Sine theta over cos theta. Okay, do you see that? Then remember, if I have divide, I can change the divide to multiply, and then the cos theta and the sine theta, they simply become reciprocals of each other. Okay, and then what happens? This sine theta and this sine theta, they cancel each other, and then I'm left with a beautiful answer that is negative cos theta. Because when these two cancel, I'm left with 1 and 1. Okay, 1 times negative cos theta is cos theta. It's all over 1, and then this basically leads me to an answer of negative cos theta. Okay, so all I did here is that this division line, since I know that this line stands for divide, I simply said sine theta divided by negative tan theta. Then I changed the divide, okay, then I changed the trig ratio, the quotient trig ratio tan theta, to the identity negative sine theta over cos theta. Then after doing that, this division sign, remember in earlier grades, this division sign, I changed it to multiply, so that this becomes the reciprocal of negative sine theta over cos theta. It becomes negative cos theta over sine theta. And then we get an answer of what? These two cancel, because obviously this is sine theta divided by sine theta, which is equal to 1. And then we are left with a negative cos theta as our final answer. Okay, some of you may have slightly done this differently. Maybe in the denominator you would have written sine theta over cos theta, and then you would have basically manipulated, applied algebraic manipulation in that state to get the answer negative cos theta. That is also fine. It's just that I quickly saw that this sine theta is over negative tan theta, so I wrote this division line as the symbol divide, which allowed me to change then the trig ratio negative tan theta to negative sine theta over cos theta. And then I remembered a simple rule when it comes to simplification, that I can change my divide to multiply, write the reciprocal of the second fraction, then it leads to cancellation, which basically leads me to the answer negative cos theta. Okay, yes, okay, so hopefully you guys can see that simplification. Okay, and basically that's how we are able to get to our answer, applying the strategies that we basically know we ought to apply. Okay, all right, so I hope that answers that question. Okay, and it answers it very nicely. And all I did here, guys, is just apply the basic algebraic strategies that we basically know. Okay, mammalian, even if it's proving an identity, the only thing with proving an identity is that you actually have the answer. It's there, it's given to you. Okay, you have the answer available, it's given to you. So proving an identity is no different from what we are doing. It's just that obviously there's different types. Okay, we'll do another one. Let's just see if I can find a nice romantic one, you know. Let's see if I can find a nice romantic one, a nice romantic problem for you guys. Nice romantic one. Okay, so this is grade 11, guys, remember? This is grade 11. So this is not grade 12, because I see people are asking me questions about adding, basically putting 2 and dividing by 2. You guys, that is specifically having reference to grade 12 with the double identity. Okay, so, and obviously that's not what we're not doing grade 12, we're doing Okay, let's see if we can't do numerical. You're quite confused. It's funny what people write in the comment sections. Like, people are quite confused. 5 o'clock. 5 o'clock, grade 12. Yeah. 5 o'clock, grade 12. You guys, I'm gonna help you out tomorrow morning. Grade 12, I have morning session with you guys. Most you know, or at least those that join in know. Okay. Okay, and then to the grade 12s, the sessions that we did last week, for instance, in the morning, I've already posted in the YouTube channel. The link is in my bio for the YouTube channel. You guys can check out those live previous sessions that we had done. Yeah. That's for both double angle, compound angle, and also like just simplification of that. Okay. Plus sine squared x. Okay, let's look at this one. So once again, yes. 5 in the morning for grade 12. Once again, guys, we're just applying. Okay, we are applying what? We are applying simplification, factorization, identity. Simplification, factorization, identity. We're applying that strategy, the 3-step strategy, where we apply simplification. When it's exhausted, we move on to factorization. When that is exhausted and it can be applied, we move back to simplification. We apply it, we exhaust it, we move back to factorization. We apply it and exhaust it. If there's nothing more that can be done with simplification and factorization, we move on to the 3-point strategy and we look at identity. You see, so we're constantly jumping between those three for the purpose of simplifying something. That is the question, guys. Cos of 180 plus x times tan of 360 minus x times sine squared 90 minus x over sine of 180 plus x plus sine squared x. I'm sure you guys can really do this on your own. You don't need me to do it for you. I'm sure you can, and I'm sure you can comfortably get to the answers yourself. No problem. Okay, you just look at it. Simplification, can we apply it? Definitely, I'm sure you guys can see. So you take down that guy, you take him down, yo, and I can see you guys taking this down. Okay, so cos of 180 plus x, 180 plus is in the third quadrant. How is cos there? I already saw someone write the answer for the first function value, and that's 100% spot on. Just with the x, not the theta, right? Please, let's remember that we don't write theta when there's another variable. We use the variable that is there. Okay, then we evaluate this one, 360 minus x, fourth quadrant. How is tan there? We put that in brackets. Whatever we evaluate, guys, put it in brackets, please. There is a danger when you don't put it in brackets. You might think that it's cos minus tan x. So there's this thing of making sure you always put it in brackets so that you can always remember that there's a multiplication relationship between the trig ratios. This one, sine squared of 90 minus x, even without thinking, it's putty. Be very careful. It's 90 minus. Remember, 90 minus would suggest that it is a... be very careful, putty. Otherwise, putty, you'll get into trouble. Yes, clutch peaks. You see clutch peaks and mammalian. More so clutch peaks. Clutch peaks has even... look at you, putty. Now it's complete. That's exactly it. Okay. You evaluated it right. Cos squared x. In brackets, right? Don't forget the brackets. Then we come down here. Sine of 180 plus x. Which quadrant? How is sine in that quadrant? What is the answer? You see? Hi, my grade 11th. Yo, Bontle, be very careful. It's not positive. Yo, it's not in the second quadrant, guys. 180 plus is not in the second quadrant. It is in the third. Hey, be careful, guys. Must I remind you? This is 180 minus. This is 180 plus. This is 360 minus. Please be very careful, guys. This is first quadrant, second quadrant. third quadrant, fourth quadrant. Please be very careful, ne? We don't want to be making silly sign mistakes. All right. Maybe to assist my friends who are very dangerously living on edge and may get signs wrong, what you can always do as well, okay, if you come back here, let's just check this out. If you say cos of 180 and then you put in the place of x, you put the number 1, okay, this is like a cheat code sort of like way of getting the sign correct. You may forget about this thing of 180 plus 180 minus. You may forget, naturally so. So if you take your calculator and you say cos 180 plus 1, you substitute in the place of x just 1 degrees. You make that a standard thing that whenever there's x, you substitute 1. You guess cos 181. Cos 181, you punch your calculator, what do you get? Do you get a positive or a negative answer? You guys tell me. That answer that you get, it's numbers, it's got decimals, but is it positive or negative? 180 plus 1. You get a negative answer, one delay. You see? Yes, Bondle. You use your calculator, cos 180. 180 plus 1 is 181. Cos 181 gives you a negative answer. That would suggest that the answer is negative cos x. Yeah, well, this is without using the quadrants. It's simply using your calculator so that you can get the sign of the particular trig ratio. Since you know it's a function value, obviously the cos will stay as cos, it won't change. Move on to tan. You do the same thing. You substitute 1. 360 minus 1, it's 359. What's tan 359? Do you get a positive answer or a negative answer? If you use that calculator of yours. Yabona mamillion. So is there a way that we can actually then go wrong if we know this as well? Aye guys, is there a way? No. Just substitute 1 in the place of x. You substitute 1, you put that in your calculator, bam, answer. You get negative tan x. So the sign will always be correct. You come here. Now you know this is a cofunct. Please guys, don't forget this. 90 minus, 90 plus, 360 minus, 360 plus. You always know, guys, that it's supposed to be a change in trig ratio. But since there's a square, we know that the answer will be positive. So I'm not even going to think much here. I'm just going to write my positive answer. Yeah, very good, Putty. That's what I love. Putty, you had made that mistake. This was you see. So I'm very happy that you were very fast to come onto the comment section and say, no, sir, it's supposed to be cos. Yes, guys, that means you are all not sleeping. You are all awake. You must all be awake. That's what I want. When you are awake, you will be able to identify these things. So very good, guys. Thank you so much. Okay. Yeah, you guys are alert and awake. So yes, it's supposed to be cos squared x, not sin squared x, because the trig ratio changes. It changes. Okay, so please just be vigilant with the 90 minus, 90 plus, 270 minus, and 270 plus, that the trig ratio will change. Sin changes to cos, cos changes to sin. We know because of the square, whatever comes out, it will be positive. This, you get the mark when you go directly from this to the trig ratio that is positive, okay, without necessarily having to evaluate the trig ratio alone with the square on the outside. You can just go ahead and you know that applying the square leads to a positive answer, so you can just write positive cos squared x. Okay, right? Okay, but I'm sure even if you evaluate it, you get a positive answer. 180 plus x, put the 1, guys. In the place of x, just put the 1. 181, sine 181. What is the sign that you get? Positive or negative? It's negative. You see, Ramo? Guys, I don't know what you... I don't know what more you want from me. I don't know. Okay, and then remember there was that sine squared x that was chilling there on the side plus sine squared x. It was just chilling there. It's added to this entire thing. But remember, guys, board math says we take care of brackets, exponents, division first. We can't take care of the addition with this thing. We first take care of the division. So we are going to simplify this fraction, and then we are going to add whatever is going to be the result from what we have here. So we are still busy with the simplification step here. We have not moved from our simplification. We are still busy. We've been busy with simplification. No factorization yet. We are still busy with the simplification. So I'm sure you can see, guys, that negative cos x is negative cos x. No factorization. Tan x, we use the identity. What is tan x? It's negative sine x over cos of x, because we are looking at the numerator exclusively. You can see the cancellation is going to be happening there very soon. Then we are timesing the what? The cos squared x there at the top. Over what? Everything is over the what? The sine of x. So look at this. Okay. And we know there's the sine squared x there. We are going to attend to it very soon. Don't worry. Okay. We're going to change. Forgot the negative. Thank you so much. Thank you so much. Thank you so much. You guys are amazing. Okay. Hopefully you guys will not do the errors that I do in the test. That because you are so vigilant and you guys are so aware. Okay. So goodbye. Okay. Of course, we say goodbye to him. He bounces. But that negative sign, negative times a negative times a negative divided by a negative, this whole thing will result in a negative thing. This sine x, guys, will cancel that one, interestingly enough. Okay, that cos x and that cos s cancel. Okay, but that sine x and that sine x will also cancel. Okay, so that means we are left with what? We are left with, this was negative, this was negative, positive, times the negative, divided by the negative. So the result of all of this is negative. Tertia, you are asking why? Why what? This cos x and this cos x, they cancel. This minus sine squared x, okay, and this sine x, they cancel. Okay, we don't make all the denominator the fractions. Okay, so I hope you guys are seeing this and you are seeing it very well. Okay, now let's be very careful, very, very careful. So negative cos x was the result of 180 plus x, right? Negative tan x is the identity, negative sine x over cos x. Cos squared x was there obviously already. Okay, over, everything is over negative sine x. Okay, negative sine x. Everything is over negative sine x. Okay, so what we are saying is that this cos and this cos will cancel. All right, that becomes obvious. When you cancel, you are left with 1 and 1. Remember, this negative sine x divided by 1 will leave you with a negative sine x at the top. Are you with me? Okay, are you with me, guys? So that's why I'm saying this negative sine x will also cancel this sine x. Okay, and then I am now left with what? This cos squared x alone. But what sign is it? Negative times a negative is positive, divided by another negative. We are going to basically have a negative cos squared x. Okay, and negative cos squared x. Okay, so I repeat again, this cos x and this cos s cancel. This sine and this sine, they cancel. You are left with a negative what? Cos squared x, because cos squared x divided by negative 1 gives you a negative cos squared x. Okay, I hope you guys now get it. But very, very careful, guys. We had a plus sine squared x on the other side. This here does not give me 1. It does not give me 1. Be very careful where that is concerned. Very, very careful. It does not give me 1. This is negative cos squared x plus sine squared x. Because of the signs, I cannot get a negative 1. Okay, remember, I would get a negative 1 if I had basically been left with negative cos squared x minus sine squared x. Then what I would do is I would take out a highest common factor, which would leave me with cos squared x plus sine squared x. And then obviously inside the bracket, I would have the identity, which is equal to 1, which would give me negative 1. Okay? Yeah. But in this situation, it's not happening. The answer, you leave it there. You see, your awareness and sensitivity to that also makes your teacher realize when you write your answer that, oh, this boy or this girl, they know when the identity is supposed to be the identity. Yes, so the answer, we leave it like this because there's nothing more we can do. Okay, where's the sine squared x coming from? Remember, there was a plus sine squared x that was just chilling there on the side. There was a sine squared x that was chilling there on the side. There was a sine squared x that was chilling there on the side. So we just made it join the simplification because we were constantly dealing here with the fraction. Okay, because we know what BEDMAS says. BEDMAS says you must take care of the brackets, the exponents, division first. So we took care of the division first. After we were done with the division, we got negative cos squared x, which now is added to the sine squared x that was chilling there outside alone. Now we let it join the expression. Yes, it is a game, guys. Then we have negative cos squared x plus sine squared x. But this here, we leave it like this. The answer is negative cos squared x plus sine squared x. We cannot simplify this any further. Why? Because as I said to you guys, as I said and I've explained and I'm explaining so much more now, the identity that you know says sine squared x plus cos squared x is equal to 1. Alright? It does not say minus cos squared x plus sine squared x will give you 1. But if these both were negative, like let's say for this instance, we would have taken out a negative as a highest common factor, then been left with cos squared x plus sine squared x in the bracket, and then this here is the identity, it's 1. Then it would have been negative 1. Then we would have said that's negative 1. But here, we leave it like this because this here is negative cos squared x plus sine squared x. And though it kind of resembles what we think this is, it actually isn't that. So we must leave it in this state. And that's where we end. Okay. Alright, so I don't know again if people now are kind of at least a bit clear with the simplification of these questions, where we have a simplification of this, but this is how simple and straightforward these questions actually are. Okay, so Kenzie, I don't know what you are saying. You are saying I must teach you the rules of identity. Remember, guys, I actually went through, the two identities that you have. You have a quotient identity, and I explained what the quotient identity is. I said the quotient identity is simply tan theta. We know it's equal to sine theta over cos theta. This is the quotient identity. Okay, then 2, you have the square identity, which says sine squared theta plus cos squared theta is equal to 1. When you make sine squared theta the subject, then it becomes 1 minus cos squared theta. If you make cos squared theta the subject, then it becomes 1 minus sine squared theta. And that's basically the identities. We can utilize them obviously as well when we make sine squared theta the subject, or we make cos squared theta the subject, and then we can express them in these various forms. But these are the two identities. These are separate and apart. Remember, if you have sine theta over cos theta, you can always substitute it with tan theta. If you have tan theta in something, you can always substitute it with sine theta over cos theta. Then with the square identity, your grade 11 square identity, this is sine squared theta plus cos theta is equal to 1. You make sine squared theta the subject, you transpose the cos squared theta, you have 1 minus cos squared theta on the other side. If cos squared theta is the subject, you transpose the sine squared theta, you have 1 minus sine squared theta on the other side. Chantel and Erstes, you're saying I must do double angles, but remember double angles are grade 12, and I have my grade 11s here on the call, and they are the ones that are basically the special guests today. But Chantel, if you want to have double angles done, I've done double angles before. You can go onto my YouTube channel. The link is in my bio. I have done a full session with the grade 12s on double angles, and it's there. It's just waiting to be attended. It's waiting to be viewed. It's waiting to be, munched up. I did a live session and I uploaded that live session there on the YouTube channel. Just check out there in the bio. It's there in the link. Let me do one question where it says prove the identity with the RHS and LHS, and then I think I will end, guys, on that note, because I have to be sleeping. I could not be able to wake up tomorrow morning if I am not sleeping, I promise you. And then the people who are anticipating for me to run a grade 12 session tomorrow will not be having me if I don't sleep. So I'm going to have to leave and love you very soon. Yes, tomorrow morning for grade Shem Kiabet. So I did promise you nature of roots. Let me do this one question on identities, then I'll do nature of roots quickly for Kiabeto, so that Kiabeto can be in the game about nature of roots. And then, guys, that will be it. Okay. Don't sleep now. I have to. Chin? What are you talking about? Me, I run on a very low battery, my friend. I'm not in a fast battery like you. I'm not power. What is it? What is that battery? Yeah, whatever the name of that battery is. It seems like you are on that battery when our next level. Okay, 1 over cos theta minus cos theta over 1 plus sine theta. Okay. Lisa, it's very much sporadic. I cannot tell you for sure when I will do a live session again for the grade 11s, so you're just going to have to watch and see and behold. Okay, 1 over cos theta minus cos theta over 1 plus sine theta. You look at the most complicated side and you simplify that one. If you look at the left hand side, it's complicated, but the right hand side, guys, it's just one trig ratio. So we can't disturb the one trig ratio, but we have a complex side this side. So the LHS, which is the left hand side, this is the right hand side. Okay, we take the left hand side. Let us deal with you, left hand side. 1 over cos theta minus cos theta over 1 plus sine theta. So what's beautiful about fractions like this, guys, very straightforward. 1 over cos theta over 1 plus sine theta. This is an addition or a subtraction of what? Of two fractions. And all I simply tell you when you are dealing with two fractions, guys, if it's two fractions, then the strategy is as follows. I know with some of you, LCD, you find the LCD, you multiply by that missing thing, top and bottom. I get you. That's all fine. That's all well and good. It will get you the answer. But for those who want to just quickly do this thing, like quick, step number 1, multiply this guy and this guy. So you have 1 into 1 plus sine theta. That's what you do with two fractions. Step number 2, multiply this guy with this guy. Okay, that means minus cos theta into cos of another theta. Then after that, that's 2, you multiply this guy with this guy. The denominators together afterwards. Okay, that means cos of theta into 1 plus sine of theta. So it's the 3, 1, multiply 2, multiply 3, multiply 1, multiply 2, multiply 3, multiply. You just multiply, guys. You just multiply. You play crisscross, 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 cress. All right. This is the same thing as you saying, what is the LCD? You find the LCD. This would be your LCD. It's like butterfly method. Very good. I love that detail. Okay. You would find the LCD. This would be your LCD. Then you would be multiplying this denominator by what is missing, which is 1 plus sine theta. What you do at the bottom, you do at the top. You see, there it is. Okay. Do you see that? Okay. Then same thing again. The LCD is still this, so you'd multiply the denominator by what's missing, which is cos theta. What you do at the bottom, you do at the top. There it is. Okay. As soon as I'm done with this session, I'll drop it there. So what's 1 into 1 plus sine theta? Now you distribute. You play the distributive laws. 1 times 1. Yes, there are many ways to prepare egg, Mrs. Zhu. 1 times 1, key 1. 1 times sine theta, key sine theta. Alright? Then minus cos theta times cos theta, key negative cos squared theta. Over cos theta into 1 plus sine theta. And you're probably sitting there and you're like, however is Sir going to get to the answer like this? So what I've just done, guys, was a simplification strategy. I added fractions. That's all simplification. And from what I can see, there's no further simplification I can do, because at the top it's not like I can add or subtract like terms or anything of that nature. So the next thing I'm going to do is I'm going to check 2. Is there any factorization that I can do here? No, it seems like there's not. 3, the next strategy, identity. Any identity that can actually be changed? Yes, there is. Look at the top. Sine theta is already a middle term. Cos squared theta I can change. 1, let it remain for now. So minus cos squared theta can be written as 1 minus sine squared theta. Identity. Did you see this one? In brackets, I put 1 minus sine squared theta, because cos squared theta, the square identity, remember this guy? Remember him? 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 Yeah, you can. So there he is. See? Over cos of 1, cos of theta, 1 plus sine theta. Okay. Now, let's move. It seems like something is happening. Hills Nuang, you are lost. You are saying you are lost. Why are you lost? The reason why you are lost is because you don't know your square identity. This cos squared theta, okay, I am looking at these 3 terms, and I'm looking at 1, okay, and I'm looking at sine theta. This seems to be my middle term, but then I don't have sine squared theta. So I look at this cos squared theta and I'm like, you got to change, you've got to change, you've got to change, you've got to change. So cos squared theta, I look at my square identity. Sine squared theta plus cos squared theta is equal to 1 is my square identity. If you make sine squared theta the subject, 1 minus cos squared theta. If you make cos squared theta the subject, then you take the sine squared theta over, you have 1 minus sine squared theta. So it's important to know the variations of your square identity. So I substitute in the place of cos squared theta, I substitute 1 minus sine squared theta. Why? You've got to change, you've got to change, you've got to change. Do you see that? Now at the top, thank you, Jane Doe. You're very generous. Thank you for the rose. At the top, I can now distribute the negative inside the 1, the negative inside the negative sine squared theta. What do I have now? Minus 1 plus sine squared theta. This is distribution. We are back at simplification, guys. That's what I'm doing. What I'm doing here is multiplication. I'm distributing. So from identity, now I'm back at simplification. This is what I'm doing. And you can see I am further going to simplify. Further simplification. So I am at the simplification strategy, guys. Only now I'm at the simplification strategy. So do you see the importance of changing this and putting brackets? If I didn't, then it would have been my loss. If I didn't put brackets when I substitute in the place of cos squared theta, this 1 minus sine squared theta, it would have been a grave mistake, because I wouldn't have been sensitive to the fact that this negative needs to be distributed to the 1, this negative needs to be distributed to the negative sine squared theta to give me negative 1 plus sine squared theta. Now, I'm still simplifying at the top. Addition of like terms. 1 minus 1 is 0. Then I'm left with sine squared theta plus sine theta over cos theta into 1 plus sine theta. Is anyone feeling me here? Do you feel me, my peeps? Do you feel me? You feel me? Man, I hope you guys are feeling me, because I'm feeling myself right now. It's not even funny. Yeah. Okay. You made a mistake. No, I didn't. I didn't make a mistake. Where did I make a mistake? Tell me. Ratse ke kutso. Rase ke kutso is saying you made a mistake. I'm listening to Rase ke kutso. Where is the mistake, my man? You made a mistake. Can you see that? Let's pin this comment. There he is. At the top, where's the squared? Which squared? I put the sine squared theta as my first term, followed by this sine theta, which is my second term. Okay. Now, remember guys, I'm still flowing with my strategy. I've just applied simplification. You remember, Moss, we were at the identities point. So I applied identity. After applying identity, I went back to my next strategy. Simplification. Simplification, I distributed the negative. I added the like terms. Those are all simplification strategies. Then I'm here. Look at this top. Look at this bottom. Simplification. Is there any other further simplification? No. Factorization? Yes. Factorization strategy. At the top, you take out the sine theta, as you guys have said. You take out the sine theta, which is the highest common factor. I'm left with sine theta plus 1. Then, what do I have at the bottom? Cos theta 1 plus sine theta. Okay. Now look at this, guys. Look at this. Look at this. It's so emotional. It makes me so emotional right now. Sine theta plus 1 and 1 plus sine theta. I can't believe this. Can be cancelled indeed. Why? Because 3 plus 4 is the same thing as 4 plus 3. You see, when there's a plus sign in between, they are the same thing, guys. 3 plus 4 is 7 and 4 plus 3 is 7. The order doesn't matter. We say addition is commutative, right? Cancel. Goodbye. Goodbye. Sine theta plus 1 from where? Highest common factor. Sine squared theta plus sine theta. When we factorize, we take out the common base that has the lowest exponent. Take out the common trig ratio that has the lowest exponent. So between sine squared theta and sine theta, sine is common, but we take out sine theta. Then we are left with what on the left? A sine theta. We are left with what on the right? A plus 1. That's where it comes from. Okay? Then cancel these two. What's sine theta over cos theta? It's the trig identity. Remember, guys, after factorization, we are at the factorization strategy stage. Then we ask, is there anything else to be factorized? No. We go back to simplification. Anything to be simplified? No. Yes. Cancel. Cancel. Simplification, done. We ask ourselves, any other factorization to be done? No. Any identity? Yes. 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 It is equal to tan theta, which is the right hand side. That's what we were wanting to prove all along. The right hand side, which is tan theta. There it is. There it is. There it is, and it's so sweet. It's a tan theta, and it's big for me and you. Man, amazing stuff. Tan theta there, guys. Like, I mean, I don't know. It's more like want to sing kumbaya type thing and stuff. Yeah. Okay, guys, that was that problem. And remember, this was not me prepared because, like I said, I came on here on the platform. I asked what do people want, and people indicated what they want, and they said trig and all of that stuff. So I did trig, and there it was. The trick was done. Okay, guys, I need to now change change the gears a little bit. Yes, guys, I have a YouTube channel. The link is in my bio. It's also called Maths is a Game 5 to 7. The link is in the bio. You can go onto the link in my bio. You click on it, go and subscribe to the YouTube channel. I think we're fast approaching 1,000 subscribers there. Last I checked, it was 900 and something, which means you guys are really hopping on there. You are subscribing. The views are very low, of course. Now you can expect that to be the case because I'm simply uploading raw sessions of what I do here onto the channel as you see them on TikTok. It's not like there's any edits or anything of that nature. So I understand that's why that is the case. But just because I have low views, guys, that does not mean those videos are not good enough. Because if you are talking about this session that I've just done now with you, then this is a sweet session, guys. I mean, really now, you know, we cooked here, and there was real cooking that happened, and the cooking was good. You know, I wasn't cooking with gas here. I was cooking with some serious stuff, if you know what I mean. Okay, now I want to go to my friend that asked me to do nature of fruits. Oh, shame, man. Waiting so patiently. Kiabeto was asking me for nature of fruits. So I'm going to do that quickly. And then I'm going to go and sleep. Sorry, guys. I have to go and sleep after this. If I want to function tomorrow well, I have to have an early sleep. Thank you so much, Liejo. I love helping out. I'm not gonna lie. I love the maths. I love it, guys. I love it. So that's why it's a joy for me to help out here. Okay. What you can help me with is just subscribe to my YouTube channel, and yeah, man, I can get YouTube to sort of like compensate me, if you know what I mean. And then I can continue doing this as well very nicely. Not that, you know, that was the whatever, but it helps. Then yeah, I'll see the grade 12s tomorrow morning. Let's look at nature of roots. Guys, let's first and foremost, do you guys know what a root is? Because I feel like that's the problem. That's where the danger is. People don't even know what a root is. Okay, so if you have if I give you an equation like this and I say solve for x, you know, I can say solve for the roots. Maybe I need to change the question. Maybe we need to change the framing of the question and say to you guys, solve for the roots. Maybe you guys would really get into the swing of things and realize, oh, when they say solve for x, it's like they are saying solve for the roots. So the x values we get are the roots. The solutions are the roots. Okay, so when you would solve for this, obviously you would nicely factorize. Okay, this here is in standard form. Then you factorize. Then you say x is equal to 0 or x plus 1 is equal to 0. You apply the zero factor law. In other words, when there's a 0 on the other side and there's a product of factors, you can take each factor, equate it to 0, and then basically find the solutions. So these are the roots. Can you see the roots? We have x is equal to 0 and x is equal to -1. These are the roots. Listen to me and listen to me very nicely. These roots, you can tell me something about their nature. You know, how they look. What is their nature? 0 and -1, they are both, you could say that the roots, they are both what? They are real numbers. So you would say that the roots are real. You could tell me about their nature. You've solved for the roots, you got them, you can see them, now you can tell me about their nature. You can say that the roots are real. Furthermore, if I asked you, are the roots rational or irrational? 0 and -1 are both rational numbers. Then after that, Are the roots equal or unequal? Of course, guys, 0 and -1 are numbers that are not equal. Okay. So what you've just done here is you've told me what the nature of the roots is by solving the equation. Okay. All right. But now you do not have to solve for the equation in order to determine the nature of roots. We can simply use what we refer to as the discriminant. Okay? Where do we get the discriminant? We get it from the quadratic formula. The expression under the square root is basically, guys, what we refer to as the what? The discriminant. Okay? I hope you understand what I mean here. That expression under the square root, all right, helps us to be able to determine the nature of roots without having to really go ahead and solve the equation. So if I was to ask you, discuss or determine the nature of roots, and I give you the equation x squared plus x is equal to 0. You don't have to solve it, because it's saying determine or discuss the nature of roots, and it says without solving the equation. Okay. When they say without solving the equation, that simply means all you need to do is you need to use the discriminant. So what you need to make sure you do when you do these questions, the method is quite simple. Make sure your equation, first and foremost, is in standard form. In other words, x squared plus bx plus c equal to 0. 2, you can then identify your a, your b, or your c from your equation once it's in standard form. 3, you take down, write the discriminant. 4, substitute a, b, and c using brackets. 5, state things about delta. State about delta 2 things: the fact that delta is positive and the fact that delta is a perfect square or not. Whether delta is a PS or not a PS. Okay? The alternative is saying delta is less than 0 alone. Okay? So if ever you say delta is greater than 0, you must say something about delta being either a perfect square, or if it's not a perfect square, you can say delta is not a perfect square. That's one of the situations. The other situation is you could say delta is less than 0, and when it's less than 0, you can't say that it's a perfect square or not a perfect square. You just simply end with delta is less than 0. Then 6, you conclude on about the roots. When you conclude about your roots, please guys, remember when delta is greater than 0 and delta is a PS, okay, because it's greater than 0, we know that the roots are real, rational, unequal. That's 1, 2, 3. You comment under those 3 headings. When delta is greater than 0, that means the roots are real. That's what greater than 0 means. When delta is a perfect square, you can then conclude that the roots are rational because delta is a perfect square. And then you say they are unequal, the roots, because delta is greater than 0. if it's delta greater than 0 and delta is not a PS or a perfect square, then it stands to reason that you will say real, irrational, and you'll say unequal. So where's the difference? The difference is just in the irrational part. Otherwise, everything else is the same. Okay? Yeah. So delta greater than 0 and delta is a perfect square means real, rational, unequal for the roots. If delta is greater than 0 and delta is not a perfect square, it means that the roots are real, irrational, and unequal. The other scenario is delta is equal to 0. That means the roots are real, rational, and equal. Okay? And then the last category is delta less than 0. That simply means one thing. Non-real roots. Full stop. You can't say more than these guys. When delta is less than 0, you just say non-real roots. Done. You don't comment under 3 things. You just comment non-real roots. Full stop. Finished. Delta equal to 0, real, rational, equal. Delta greater than 0, real, rational, unequal. If delta is greater than 0 and delta is a perfect square, roots are real, rational, unequal. Delta is greater than 0 and delta is not a PS, real, irrational, unequal. Okay, so look at this question. I'm going to follow all my steps here. So first and foremost, equation must be in standard form. So that's accomplished. Step number 2, A, B, and C. A is equal to 1, B is equal to 1, C is unavailable. We don't have a constant term, so that means C is 0. It was the equation in standard form? Tick. Did I identify A, B, and C? Tick. Delta is equal to B squared minus 4AC. That's the next thing I'm going to do. Delta is equal to B squared minus 4AC. That's my discriminant. Step number 4. Substitute A, B, and C using brackets. Delta is equal to, in the place of B, 1 squared. In the place of A, 1. In the place of C, 0. Okay, do you see that, guys? In the place of B, 1. In the place of A, 1. In the place of C, 0. Next step, 1 squared. 1 minus 1 squared is 1. 1 minus 4, negative 4 times 1. Negative 4 times 1 times 0, that's equal to 0, guys. Sorry, I nearly butchered there. Negative 4 times 1 is negative 4 times 0 is 0. 1 minus 0, give 1. Substitute. Now I've got my value of delta. Now I need to say something about delta. Delta firstly is greater than 0. Delta is a perfect square. Okay, guys, you write down, you can write perfect square. I've just written PS for short, perfect square. So delta is greater than 0 because 1 is a number that's greater than 0. Delta is also a perfect square because the number 1 is a perfect square. Now I can conclude about the roots. The roots are, okay, since delta is greater than 0, the roots are real. 2. Rational or irrational. Since delta is a perfect square, the roots are rational. 3. Since delta is greater than 0, the roots are unequal. Full marks. Full marks, guys. Full marks. Full marks. Full marks. Everything has been taken care of. So that is one type of question you get for nature of roots. The question that says, discuss or determine the nature of roots. Are you with me? Okay, I hope you are with me with that one. Okay, discuss or determine the nature of roots. Okay, yeah, all right. Discuss or determine the nature of roots. Okay, so let's just look at another one. It's funny, people are saying a harder one. Discuss or determine the nature of roots. Okay, kaloku, when you do a question, guys, you need to start a bit, at low level, then you take it one step at a time. So just hang on. Okay, 2x squared is equal to 5x minus 2. So first step, standard form. Okay, no, that's not a harder question. Determining the value of k is not a harder question. It's just another type of question for nature of roots. So these ones that I'm doing are like type 1, discussing or determining the nature of roots without solving the equation. Okay, standard form, a is equal to 2, b is equal to negative 5, c is equal to 2. I'm going to get there just now. Okay, then I write delta is equal to b squared minus 4ac, b negative 5 squared, 4a 2, c 2, 25. What's 4 times 2? It's 8. 8 times 2, 16. 9. Delta is equal to 9. Conclusion, delta greater than 0. Delta is a PS. Roots, real, rational, unequal. Okay, right. So of course, guys, if let's say we had gotten an answer that said delta is equal to 0, then we would have said in our conclusion, roots are real, rational, equal. Okay, if we had gotten an answer that says delta, let's say we had gotten an answer saying delta is equal to negative 7, then we would have said delta is less than 0, then we would say the roots are non-real. If we had gotten an answer where delta is not a perfect square, and we had said, let's say delta is equal to 14, then we would have concluded that said delta is greater than 0, delta is not a perfect square. Therefore, the roots are real, irrational, unequal. You guys get the point, right? So that is basically the questions of determine or discuss the nature of root. PS simply means delta is a perfect square. You didn't think it was the chocolate, did you? Okay, because 9 is a perfect square number. Okay, you guys are already, you're still drunk on Valentine's, drunk on the Valentines that you just came from. Okay, let's do the second type. Type 2 of nature of roots questions have to do with for which values of a unknown. Okay, for which values of a unknown. Now that unknown can be any other letter. It can be A, can be B, can be C, can be D, can be F, can be G, can be K, can be L, can be T, can be M. This other unknown is another letter besides X. We then have to actually find that value. So let's check out a question that basically mimics what I'm saying. A question says, for which values, okay, of K will the roots of 2x into x plus 1 equal to x minus k be? And then they say condition 1 equal, condition 2 non-real. Okay, so I'm going to look at this type 2 of nature of roots. Questions that say for which values of a particular unknown, okay, of a particular equation will be equal. So for which values of k will the roots of 2x into x plus 1 equal to x minus k be equal? So let's just write down the method for this question. These types of questions, we need to do the following. Step number 1, equation must be standard form. You know most what standard form is, ax squared plus bx plus c, but the equation must be in that form. 2, you identify a, b, and c. 3, set up your equation or inequality using the condition. Now you are going to ask the condition of the roots. Now if you look at this, it says for which values of k will the roots of this equation be what? Be equal. So what does equal roots mean for delta? That's what's important here, because that's how you go about setting up your equation. You need to look at what does equal roots mean where delta is concerned. Okay, because it is delta where you are going to actually set up your equation for equal roots. What does it mean for delta when roots are equal? So for equal roots, it means delta is equal to 0. That's how you would set up your equation. So you need to know all the conditions. So for equal roots, we know delta is equal to 0. What about for non-real roots? What does it mean for delta? Okay, I liked what Asande helped us out there in the comment section. He said delta is equal to 0. What about for non-real roots? Delta is what for non-real roots? You need to know how to set up, guys. Setting up our equation is of utmost importance. It is delta less than 0. Very good. What about for real roots? What does it mean for real roots? Delta is what for real roots? Come on, comment section. You guys are coming on very nicely. Comment section. Okay, Ditebucho is saying delta is greater than 0. Kiabeto is saying greater than 0. Swakile is saying delta is greater than 0. Y'all smart. You guys have good teachers. Lee. Okay, guys, it does not just mean delta is greater than 0. It means delta is greater than or equal to 0 for real roots. So it's not enough to just say greater than 0 alone. It means delta is greater than or equal to 0 for real roots. What about for real and unequal roots? Note that, please. Note it. Otherwise, you will butcher your lives in those tests when you write them. Okay? When they say for real and unequal roots, what does it mean, guys? Setting up the equation for delta. What does it mean for delta? Real and unequal. Don't mind my foolish handwriting. You guys get the point most. For real and unequal roots, it means delta is... Guys were coming on very nicely. For real and unequal roots, it means delta is... Hebana. Quietness in the comment section. Real and unequal. Real and unequal. What does it mean for delta? Thank you, Tabiso. Delta is greater than 0 alone. No equal sign because it says real and unequal. This one said for real roots alone. So real roots means delta is greater than or equal to 0. But now it's saying real and unequal. So that means delta is greater than 0. And then lastly, when they say for equal roots, what does that mean? Or we already know because we already stated it. So hopefully you guys remember what you said initially. Okay. Thank you, Swakile. Thank you, everyone. So I hope you understand. Okay. Do you see the question, guys? It's different from the type 1 that we looked at. This one says for which values of k will the roots of this be equal? So we're going to have to first answer the question for equal roots. So this here helps us out. Standard form, identify A, B, and C, set up equation or inequality. Sometimes it's going to be an equation you are going to have, like for when it's equal, but sometimes it's going to be an inequality, like when you have less than, greater than, or equal to, or greater than 0. You're going to have an inequality. And remember, your inequality may be linear, as per your grade 10 syllabus when you solve the linear equation, linear inequality, or your inequality can be quadratic. Just like you've solved and you've been solving here in grade 11 a quadratic inequality. So you must remember the same steps that you take when you are solving a quadratic inequality. So let's look at this question. Step number 1. take the equation, write it in standard form. 2x into x plus 1 is equal to x minus k. So let's go standard form. 2x, we distribute. Yes, I do have a YouTube channel. The link is in my bio. Maths is a game 5 to 7. But you can go to the link in my bio. You click on it, it will send you directly to my YouTube channel. 2x times x, 2x squared. 2x times 1 plus 2x. X minus k, we just transpose minus x plus k. Remember, when you transpose things from one side to the other, the signs will change for those terms, okay? Don't forget that. Then we have like terms, 2x minus x, that gives us x plus k, which is equal to 0. So we have a standard form. A, we can identify, it's 2. B is 1. C is k. Okay, now you guys were saying the more difficult ones, the ones where you have to solve for an unknown. Guys, this is easy. It's whack. It's also not difficult. It's easy, these questions. Okay, nothing in nature of roots is difficult. All of it is easy. Okay, that's why I'm saying to you guys, you can get 100% in maths for grade 11. There's no joke about it. Like, I'm not kidding when I'm saying that. It needs someone who is disciplined, who has high discipline, high morale, and then the performance will just line up. Okay, so anyways, A is equal to 2, B is equal to 1, C is equal to K. Let's remember, what was the condition saying? For equal roots. So we know delta is equal to 0. For equal roots, we write delta is equal to 0. What is delta? Delta is b squared minus 4ac. So I'm saying equal to 0. Now I substitute b, 1, 4a, 2c, k equal to 0. Then I solve. And you people are saying it's difficult, this thing. Hi man. Yeah, then from here on, you should definitely know what to do. Okay. So I hope my dearest friend, the one who asked, is getting it. We're getting the swing of it, you know. That's very key, that we get the swing of it. You transpose the 1, you get -1, you divide both sides by -8. You get k is equal to +1/8. This is the value of k for which the roots can be made equal. So if you were to take this k value 1/8 and substitute it in this equation would then be the type of equation that when you solve, you will get roots that are equal. Only when you substitute 1/8 in the original equation and you would solve it, you would get roots that are equal. What does equal roots mean? That's like when you're solving an equation and you actually find the following. You know, when you are solving an equation, and let's say you get to a place like this, x minus 3 into x minus 3, and then you get an answer, x is equal to 3 or x is equal to 3. Guys, this is the same thing, man. This is the same thing. This is what equal roots mean. The roots are the same. When you are solving an equation, you get roots, but they are the same thing. Then basically, this is what we mean by equal roots. Okay, so that means when we substitute k is equal to 1/8 in this particular equation, we are going to get an equation where we are solving and we get 2 roots that are the same. Okay, all right. Yo. Hi guys, I don't know about you. Then there was a second condition which said for non-real roots. So for non-real roots, remember, I already have the standard form of this equation. Yeah, maths maru, very true. Okay. Then a is equal to 2, b is equal to 1, c is equal to k. Okay, remember from the previous question, I already figured out what the standard form is. Okay, I don't know why this thing, it just becomes blurry sometimes. I don't know why. Then for non-real roots, delta is less than 0. We do the substitution again. B squared minus 4ac less than 0. B is 1. A is 2, C is K. So what I'm going to get here is a linear inequality, 1 minus 8K less than 0. Negative 8K less than negative 1. Linear inequalities from grade 10, those were easy. Remember, we are going to divide both sides here by what? By negative 8. My champ. It said for non-real roots. Okay? Yes, for real roots, you would say delta is greater than, here it is, guys. Here, for Homo Mutsepe, if you've just joined, we did stipulate all the conditions. For equal roots, delta is equal to 0. For non-real roots, delta is less than 0. For real roots, delta is greater than or equal to 0. For real and unequal roots, delta is greater than 0. And then I just happen to repeat for equal roots again. We know that delta is equal to 0 for equal roots. So these are very important so that whenever we are getting to this stage, we can just simply state for non-real roots, delta is less than 0. We substitute, we solve for our K value. So I said we are here at this stage. We're dividing by negative 8. Remember what happens when we divide? The inequality sign changes the direction. Changes the direction. It was less than, now it is greater than. We get an answer of K is greater than 1 over 8. Mets marung. Yo, hi guys, it's Mets marung. It's Mets marung. Hi, give Mets marung. Give Mets marung. Okay. Remember, whenever you divide the coefficient of the variable that has the highest exponent in your linear inequality, what happens is that the inequality sign changes direction. Yes, the sign only changes if you divide by a negative coefficient, not by any other coefficient. If it was a positive coefficient, the inequality direction would not change. But because we are dividing by a negative coefficient, very important to note, negative coefficient, the inequality direction has then changed. Alright? Negative. If you are dividing by a positive coefficient, it wouldn't change, guys. It's the sign here. Dividing by a negative coefficient leads to a change in the direction of the inequality sign. Are you with me? Yeah, I hope you are feeling this thing. Guys, that's for which values? Okay, that was an example for which values. For which values has type 2.1. Okay, where they give you, they say the roots of an equation x are, and then they say maybe x is equal to 3 plus minus p squared minus 4 over 2. Look at this, guys. The roots of an equation are, there we have them. X is equal to 3 plus minus the square root of p squared minus 4 over 2. And then they say, for which values of p will the roots be, when they say be real? Okay, now in this situation you are not given the equation, but you are given the roots of an equation. These are the solutions of x for a particular equation which you don't know. All right, then they are saying for which values. You see, it's still a for which values question, just like type 2 obviously is a for which values. That's why I say this is type 2.1, and it's when you are given the roots of a particular equation and they ask you for which values of p will the roots be real. So no equation, meaning there's no standard form, there's no identification of a, b, and c. The question is, we need to set up an equation. We use delta. What is the condition? Delta is for real roots. What do we know for real roots, guys? For real roots, delta is what? I want someone to tell me in the comment section. Okay, we even set up, Andy, so thank you for the rows. For real roots, delta is? For real roots, delta is? Be careful for real roots. Okay, let's go back to our table of setting up equation. We said for equal roots, delta is equal to 0. For non-real roots, delta is less than 0. For real roots, delta is greater than or equal to 0. Be careful. For real and unequal roots, delta is greater than 0. So we said for real roots. So that means for real roots, we know that delta is greater than or equal to 0. This is our setup of the equation with delta. Please, guys, read the statement and the accompanying delta condition. Delta is greater than or equal to 0 because they said for real roots. So we know for real roots, delta is greater than or equal to 0. Okay, now you are going to come back and be like, then if there's no equation, say, where are we going to get delta? That's also my question to you. Maybe someone can tell me in the comment section. This is what we are given, guys. Delta ugai. Bua, bua. Delta ugai. Bua. Teta, kuluma. Oh, look at Swakile, hey? Swakile. Oh, Diallo. Swakile and Diallo, you guys make a beautiful combination. Swakile is like p squared minus 4. Diallo is like under the root sign, sir. I love it. Diallo, you guys are rock stars. You guys are freaking amazing. Freaking amazing. I need to give you a round of applause there. Like, I have to give it to you. Totally. Yes. So we set up delta is greater than or equal to 0. Where is the delta? Underneath the square root, guys. Remember, these are roots. And this is giving me like quadratic formula kind of style. B plus minus the square root of b squared minus 4ac. Oh, under the square root. That's why Diallo said under the square root. B squared minus 4ac under the square root. Delta is located under the square root. Thank you. So all I do is I say p squared minus 4. All right, there it is. Delta. Okay, no need for, anything else. There it is. Then I say greater than or equal to 0. What is this? It's a quadratic inequality. Have I learned how to solve quadratic inequalities? Yes. In this syllabus already, I did that. So all I need to do is factorize p squared minus 4. Then I need to find my critical values, because remember, when I'm dealing with a quadratic inequality, I need to follow the steps that I know I ought to follow when I am solving a quadratic inequality. So these are my critical values. P is equal to -2 or P is equal to 2. Then the condition is saying greater than or equal to 0. This is where y is positive. In other words, this is above the x-axis and it's away from the critical values. Above the x-axis and away from the critical values. When they say greater than 0, that means y is positive. When they say equal to 0, it means on the x-axis. Okay, so obviously this is my graphical representation. My smallest critical value is -2. My biggest critical value is +2, right? And what am I looking at? Greater than 0 means above the x-axis. So my answer will be located above the x-axis. What x values show the function being above the x-axis? It's all the values that are on the left-hand side of -2. In other words, the values that are less than -2. P is less than -2. Or the values that are greater than 2. P is greater than 2. these are my solutions. Those are my values of what? Of P, whereby the roots will be real. Did you see that, guys? Did you see that? Did you see that? Did you see that? So basically, my content knowledge of what I've done in algebra so far needs to be just spot on. Spot on, guys. Okay? Yeah. Remember, if this here in this stage was less than, then I would be looking at where y is negative, and that simply means below the x-axis. Okay? Below the x-axis. And below the x-axis means between the critical values. Okay? Right. So just one more time for those who didn't hear. So p plus 2 into p minus 2, remember the step after finding the factors, I need to write down the critical values. So what I did, the inequality is in standard form firstly. Secondly, I write my factors. P plus 2 into p minus 2, okay, greater than or equal to 0. Then I write my critical values. Okay, these are like my solutions of p. P is equal to negative 2. What would make this bracket 0? It's when p is negative 2. What would make this bracket 0? It's when p is equal to positive 2. Then I just draw a graphical representation of p squared minus 4. I put the negative 2 here. Okay, my smallest critical value first, my biggest critical value last. Then I draw a graph that is concave up because the coefficient of p squared is positive. Okay, yeah. And then that then means, guys, very simply, that if greater than 0 is there, it means y is positive. That's what it means. Greater than 0 simply means that my output is y. It means I'm looking for where y is positive for my particular function. So where is y positive? Y is only positive if you go with my function. It's positive, 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 positive. Then at here it's 0. It's equal to 0. It's on the x-axis, which means I'm also looking at equal as well. All right, I forgot to put that part. Okay, on the x-axis I'm looking at, because remember I said y is positive. That's what greater than 0 means. Okay, it means y is positive. Equal to 0 means on the x-axis. So if I go with my graph, we are greater than 0, greater, because y is positive above the x-axis. On the x-axis, it's equal to 0. So all these values, this side, all of these values, we are looking for the values of p. All of these values, which are basically marking my y values that are positive. All of these x values are values that are less than negative 2. All of these values on this side of the x-axis are values that are less than negative 2. That's why I say p, meaning all of these values are less than negative 2. But then we also include on the x-axis because there's an equal to 0, which means on the x-axis. Okay, are you with me, guys? Yes, user 9371. If it had said less than 0 here, it would mean y is negative. Okay, then let's look again. Then we go down. When we go down here, this is y being negative because it's below the x-axis. All the way down here, back to this point. Here on this point, we are on the x-axis. Then as we continue to move up, you can see that we are above the x-axis. This is where y is positive again. But where is y positive? It's when these x values are greater than 2. So that's why I say p is greater than 2. All of these x values, this side, are x values that are greater than these 2. So that's why I say p is greater than 2. Okay. But then remember, I must also put the equal sign. The equal sign. Okay, so that's basically that one. For which values? Any questions about that? Okay. Had it said p squared minus 4 is less than 0, then it would have been the same thing. Okay. Critical values, p is equal to negative 2 or p is equal to 2. Graphical representation, this means what? Y is negative. Alright. Fortunately for this one, since it's less than 0, non-real, it's only where y is negative, not on the x-axis, but only where y is negative. Y is negative where? Below the x-axis, and for the x values, it's between the critical values. Between, which means it's a combined answer. Okay? Below and between. I usually say the less than 0 or less than equal to is simply what I refer to BB, below and between. I usually call them the BB, below and between, and then greater than 0, I usually call them the above, AA, above and away. That's why I know that the answers, they are separate, this or that, because they are above and away. Away from this critical value, away from this critical value. But this one, below and between. So the answer is between the critical values. Below. Okay, we have negative 2 and 2. So when you write the answer, you write the x in between. All your inequality sign, they just point, they open their mouths towards the right. And then you write your smallest critical value, your biggest critical value, and that's it. They are combined. This means x is greater than negative 2 or less than 2. Why do we say x is greater than 2? Because remember that the mouth is opened towards the x. That's why we say x, when you read it this way, you say x is greater than negative 2. And all of these values this side are actually greater than negative 2. Okay. Or you can say minus 2 is less than x, which makes sense as well. Minus 2 is less than x, okay, and x is less than 2. That's fine as well. If you want to read it from left to right, minus 2 is less than x. In other words, this value is less, okay, than your values this side. Indeed, they are. Minus 2 is less than x, less than 2. Okay, so that stands for in between the critical values. And that's that. That's type 2. And then there's the last type of question. Type 3, guys, of nature of roots. Find an integer of k. Oh my goodness, find an integer of k. Unfortunately, I don't have a working example. Alright. I don't have a working example here. Unless Kiabeto, you can actually, I don't know if you have one with you at the present moment, since I didn't think of one. If you have one, I can always invite you as a guest, and maybe you can show it on the screen and then I can do it. Okay. If you have one, then just request, and then I'll have you hop on so that you can. Okay, the last one is your show that, okay, or prove that, where your nature of roots are concerned. Show that or prove that. Okay, I usually call them type 3. Show that or prove that. Okay, so I'm just gonna show you what I mean by that one. Okay, by just looking at a particular example. So for instance, this question, okay, once you find your question, Lantuka Kiabeto, you can just request, like I said, and then You can show it up. It's grade 11, Nepresh, it's grade 11, it's grade 11. Someone asked a question on nature of roots, so I'm just rehashing on that, the three types, which I'm sure you are sort of like flowing in because yeah, this is no different from the session that I did on Thingamabob from the YouTube Thingamab thing. Let me try. My problem, okay, with this thing is that sometimes I tend to not get it right. Okay, you're on, right?
Yes.
Okay, so let me just try and do this. Okay, so I don't know if you can show it like on your screen, and then what I'll do is I'll write it down, and then I'll hop back on and then check to do it. What does the question say? Are you winning?
Yes, I'm still looking for it.
Oh, okay, still looking for it.
It's that one. If you can see.
Okay, I think it may just be slightly off focus. But can you read the question? Which one? Which one specifically? But even you can see there with Kiabet was the questions that she's shown. So K is an element of integers. Okay, so I can't. It's a bit out of focus. But can you just read the question? What does it say? Because it's slightly off focus. Maybe if you read the question, I'll just jot it down and then we'll look at it. We'll do it.
It says find the integer of k
Okay, find the integer of k, yes?
for which the roots will be rational and
Find the integer of k for which
the roots will be rational
the roots will be rational, yes?
and unequal.
And unequal, right?
Yes.
Okay, and the equation that they've given us is?
K is equals to x squared minus 4 divided by 2x minus 5.
Oh, it's that one.
Yes.
Okay, neat. Okay.
K it's not equals to 1 over 5.
Sorry, it says?
K it's not equals to 5 over 2.
Oh, okay. Okay, that's very wise of them to say, because we have a denominator that's 2x minus 5. And if that was to be, if the x value was to be 2 over 5, we'd have a problem because it would be undefined.
Yeah.
Okay, neat. Okay, I'm just gonna have to, I don't know. Let's do this quickly. Otherwise, I've got the question. I see what it says. I see what it says, so I'll do it now. Let's do this. I just need to leave the guest situation.